This is Goddess of Science Physics, and I'm Mrs. Bolden, and today we're going to talk about sound in air, which is part 2 of my sound series. All right, let's get started. As a source of sound vibrates, a series of compressions and rarefactions travel outward from the source. Oh my gosh, so many big words. What the heck does it mean? Well, we're going to explain. Okay, so when you clap, it produces a sound pulse that goes out in all directions. If you're standing behind somebody that's clapping, you can still hear them. If your back is to the person that's clapping, you can still hear them because the sound goes out in all directions. Each particle moves back and forth along the direction of the motion of the expanding wave. So remember, sound is a longitudinal wave. So the particles are vibrating back and forth in the direction that the wave is moving. So, oh my gosh, a lot of this all at once. I apologize. So a compression travels along a spring similar to the way a sound wave travels. So this would be the source of the sound, like you're hearing my voice. And that scrunches up some of the air. And if it's scrunching the air in one place, it must be like spreading out the air in another place. So this is what we call where it's scrunched up, that's a compression. And where it's a little bit thinner and stretched out a little bit more, that's a rarefaction. So a compression is a pulse of compressed air. Wow, that makes sense. The molecules are more squished together. A rarefaction is a pulse of low pressure air because the molecules are more spread out. There isn't as many together. So you can kind of visualize this compression, rarefaction, compression, rarefaction, compression, rarefaction, compression again. Remember when we had a transverse wave, we had it went up and then it went down and up and down, and it's kind of the same thing, only it's in a very linear fashion. Okay. For all waves, it's not the medium that travels across the room, but the pulse that travels. It's the pulse of energy that's doing the traveling, not the individual air particles. It is the energy, and we talked about this in chapter 25. The particles get disturbed, they disturb the particles next to them, they disturb the particles next to them, next to them, next to them, until finally the sound makes it to your ear. So consider sound waves in a tube. If you strike a tuning fork here close to the end, what's happening is it causes pulses to move through this tube, and you see some compressions and then some rarefactions and compressions and rarefactions again. So as the source vibrates, it makes a series of compressions, compressed air, and then thinned out air, rarefactions, if you will. Okay, well, that does it for this time. Thanks for joining me. Have a great day.